Okay, for determining the max height, what you did up there, I believe, was completing the square. I didn't go through all of it because I knew I was just going to do it anyway to check the solution. So even if you did it correctly, it doesn't hurt to look over. So first thing we do is we divide that negative 4.9 out of our first two terms. So negative 4.9 is going to end up here. We'll get t squared. But 27 divided by negative 4.9 gives us negative 5.5. Negative 5.5t. And then I always put my two things right. Woo, that was aggressive. Right there. And then that positive 2.4 is going to get kicked out to the end. This one's going to be a plus. This one's going to be a minus. Let's break this guy up in half. Negative 2.25, negative 2.25. We have to multiply those together. Let me double check. 5.5 divided by 2 is... Haha! See? That's why you don't do mental math. You don't do it because you could screw up the whole thing and then be kicking yourself like you did up there. Ha 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 ha. Okay. 2.5 squared gives us 7.56 plus, this is going to be 7.5625 minus 7.5625. And then we want to get rid of that one by kicking it out. So we're left with negative 4.9 t squared minus 5.5t plus 7.5625, close bracket. The 2.4 is out here. But now, negative 4.9 times negative 7.5625 gives us 37.1. I'm rounding this one. I don't feel like writing out. So now I can go, I know that my two brackets were those. You could skip this step and go right to the answer, but I want you to see where I'm getting it from. I always have the students write out those two values just because then when they get to this step where they're trying to create their vertex form, they actually remember what the numbers were. Plus 2.4, 37.1 plus 2.4 is 39.5. So, negative 4.9 t minus 2.75 squared plus 39.5. What does this question want? Determine the maximum height of the balloon. Therefore, the max height of balloon is 39.5 meters. And just for fun, and it reached it at opposite the vertex, we would take out the positive 2.75. That's when it happened at 2.75 seconds. Okay, keep going. Rectangular garden measures that by that. Both dimensions are to be extended by the same amount. Oh, this is horrible. Okay, I love this question. It's an awful question. There's no way any grade 10 ever figures this out on their own. But it's an awesome question. Okay, 5 by 7. Both dimensions are to be extended by the same amount. So what we're going to do is we're going to extend this side by that amount, and we're going to call it x. And we're going to extend this side by that amount, and we're going to call it x, because it's the same amount on either side. So you've created this extra long all the way around. Okay? So we know that each side is getting like a rectangular garden. Both dimensions are to be extended by the same amount so that the area of the garden is doubled. Determine how much the dimensions should increase. Show your work. So they are going to increase by, we don't know how much. That's what we're trying to find. But I know that it'll be 5 plus x, which will be one side of the garden. And then it'll be 7 plus x on the other side of the garden because it's getting bigger by that amount on either side. What do we know about it? Well, we know that when you double it, you're actually going to get both dimensions are to be extended by the same amount so that the area of the garden is doubled. So the original area is 35 meters squared. So if we're going to double that, it's going to give us 70 meters squared. Okay. Determine how much the dimensions should increase. Show your work. Well, this is a whole unit on quadratic formula and finding the zeros. So if we're trying to find values of x that are going to make this statement true, we're looking for the zeros. I think the best way to tackle this is to convert it to standard form and use your quadratic formula and find your x1 and your x2. So let's do that. FOIL 35. I'm skipping some steps. 7, 8, 9, 10, 11, 12, 70. So then we get, I'm going to rearrange this because I don't like it in that order because it makes my brain hurt. Okay, now we're going to isolate. So, well, not isolate. We're going to set one side to 0. Subtract 70 from both sides. So we get x squared plus 12x. This becomes minus 35. That's interesting. And then can I factor that? Two numbers that give us negative 35 and add to give us positive 12? No, it's the negative that throws that off. Okay, so our A value, our B value, our C value. If this was like a plus, if this was a minus and that was a plus, then it would work out, but the signs are why we can't factor that. Okay, x is going to be negative b plus or minus the square root of b squared minus 4 times a times c. So a negative times a negative here is going to give us a positive under the square root sign. Always a good check because then you know your math is going right. You can still make a lot of mistakes, as is evident by yours truly. Okay, stop talking during this stuff because this is where I screw up. 144 plus 120. Yep, that makes sense. Okay, that's just the under the square root sign though. 284. I believe that is a perfect square rootable number. Nope, I lied to you. Negative 12. No, so I'm gonna show the, sorry about that. I tried doing the square root of 284. She's not nice. So let's go. X1 is the negative 12 plus the square root of 284 divided by 2. And the x2 is negative 12 minus the square root of 284 divided by 2. Okay. Negative 12 plus the square root 284 close bracket equals divided by 2 equals 2.4. 2.4, x was in meters, right? And then this gives us negative 12 minus the square root of 284 equals, that's a negative number divided by 2. I get a negative answer here. You can't have a negative area, right? Can't have neg area. So this is how much each of the dimensions should increase. So, whoops. So if it was like this is 5 and this is 7, now you're going to take it up 2.4 and you're going to add right here an extra 2.4 and you've made the property double the original area. Okay? So therefore, what is it? Should increase. Therefore, each side should increase by 2.4 meters. Noise.